The Installer app is a great piece of kit to have when you're in the field installing systems, or if you're in the service organization working on systems after the sale. In this video, we'll teach you how to troubleshoot the production, consumption, and storage CTs in the field while using the Installer app. This updated training will be using the Installer app version 4.4 with the latest IQ Combiner 5 with an installed storage CT. After watching this video, you'll be able to explain what hardware is used for the data being displayed on the Installer app. You'll be able to access the data in the app and identify when the production CT, consumption CT, or storage CT is installed incorrectly. And lastly, you'll be able to list 3 examples of how a consumption CT could be installed incorrectly. There are a few requirements that will have to be met to be able to utilize the Installer app for troubleshooting CTs. You must have an installer portal login with access to that customer site. You must also be Ensemble certified through the Enphase University and hold the Sunlight Backup or Battery Storage certification. Lastly, you'll need to have the Installer app installed on a mobile device that you'll be using for the troubleshooting. The Installer app has a wealth of information available to you when you're in the field, and knowing how to use that data within the app will set you on a path of commissioning efficiency and reduce truck rolls for issues. This section will explain how the installed hardware affects the data in the app and how to figure out what the data is telling you. Starting with the production CT, the CT measures current flowing through the middle of the sensor. The current that is measured is coming from each of the PV circuit's L1 conductors that are passing through the middle of the CT sensor. No other conductor should be routed through the middle of the CT, only the line 1 conductor from each PV circuit. For this training, the production CT sensor will be referring to the black circular donut, and the CT wires will be referencing the secondary wires attached to the CT sensor. It's also important to remember that CT wires for the production CT should never be cut or extended. This will void the ANSI compliance certification. When you're commissioning a system using CTs, the Installer app will display data from each of the CTs during the Meter Wizard configuration. Understanding the data on the screen and what piece of hardware is providing that data is key to the data and hardware relationship. In the production CT setup of the Meter Wizard, the current power production data that is displayed on the screen is coming from the measured current from the production CT. The gateway is measuring the current from any wire that is routed through the middle of that production CT. The gateway will then measure voltage from the same phase line and display the calculation as wattage. This value will never be a negative number if installed and wired correctly. Remember that the conductors that are routed through the production CT are going to be the line 1 conductor from each of the PV branch circuits. The key takeaway here is that the data under the current power production is coming from the production CT. With the consumption CTs, the data being displayed is coming from the individual measurements being made for each of the consumption CTs. Like the production CT, the gateway is measuring the current flowing through the middle of each of those consumption CTs and displaying that data in the L1 and L2 boxes. The total home load is the value that is derived from adding the L1 and L2 values together. Lastly, there are 3 wire colors of the consumption CTs that are being shipped with the IQ Combiner 5. The clamp style CTs come with the red and black wire, a purple and brown, and the battery CT has a blue and white wire, which is shown on the screen. All of the CT function the same way and have the same accuracy. They just have a different color to distinguish which CT goes on which phase line or battery. The key takeaway here is that the data displayed under the consumption CT data, L1 and L2 boxes, is coming from the consumption CTs. Now, if you're going to be troubleshooting CTs after the initial installation and commissioning, you're going to have to disable those CTs. Disabling them is going to let you start from scratch like it's being commissioned for the first time. Now, to disable the meters, you're going to have to open the Installer app and navigate to your customer site. Locate the validation section and see if the meters have previously been enabled. If you look to the left, you'll see that there is a check mark next to these. That's going to show us that these have already been enabled, so we know we have to disable them now. Now, to disable the CTs, what we want to do is to tap on the meter that we want to disable. Once we do that, we can scroll to the bottom of the page and tap the disable link. Make sure you do this for each of the meters that have already been enabled so that you can start the wizard from scratch. Once they've all been disabled, restart the wizard by tapping on the production CT in the meter configuration section and start that commissioning process again. Anytime the CTs are disabled on the system using the installer portal or the Installer app, any reverse polarity flags that have been previously set, they're going to be cleared and put back to default settings. The same goes for the meter start date. The meter start date will be reset to the date when the CTs are recommissioned, and any previous data will be ignored and not included into any meter configuration calculations being displayed for the end user. With both production and consumption CTs now disabled, we can go ahead and start the commissioning process from scratch. Let's start with the production CT and work through the meter wizard. Now, to use the troubleshooting method, it does require a person doing the troubleshooting to be on site with the gateway, since the installer app will have to be connected in AP mode. Once you're on site, start by opening the installer app and finding the site you need to troubleshoot. Start AP mode on the gateway, connect your phone to it, and once you're connected, then you can go ahead and tap on the validation step and the production meter. With the PV breakers on, start by verifying that the current power production and the L1 readings are a positive value. You should also make sure that the value displayed makes sense. For example, if you've installed a 3 kilowatt system and it's a bright sunny day, you should expect to see roughly 3 kilowatts of power being displayed. That is, if all of the PV L1 conductors are routed correctly through the middle of that production CT. As a visual reference, it may be interesting to turn on the live status view to see where the power is coming from and going to. If all of the values look correct, follow the instructions on the screen and tap the checkbox next to enable the production meter once the task has been complete. If you see a negative value, you can be pretty confident that you've either got a polarity issue with the CT sensor, you have your wires incorrect at the gateway, or you've got a phasing issue. Remember from the previous sections that you should not see any negative values, and you'll have to fix the issues before you can continue on to the next step. So let's start by troubleshooting that production CT sensor and checking that polarity. First, check the CT sensor. If an Enphase combiner box has been used, the production CT is in the bottom left of the box. The arrow on the CT sticker should be pointing up towards the top of the box. While you're looking at the CT, you also may want to notice that the production CT has a flat side and a beveled side. The arrow on the sticker is always going to point towards the beveled side. This is a great tip to remember if the stickers were to ever come off. Arrow points towards the beveled side. Check that only the line 1 conductors from each of the PV circuits are routed through the CT. For example, if you have 4 branch circuits of PV, there's going to be 4 line 1 conductors going through that CT. It's also important to note that if your system is utilizing a grid-tied battery, and the battery breaker is landed in the same box as your PV, the line 1 conductor from your storage circuit will not be routed through that CT. Verify that it's outside of the production CT. With the secondary wires of the CTs, they need to be connected to the correct terminal blocks on the gateway. The white and blue wire from the production CT should be connected to the P1 terminals, with the white wire connecting to terminal 1 and the blue wire connecting to terminal 2 as shown in the picture. Make sure that the wires are also secure. Remember to reference the schematic for correct wire placement. When tightening the terminal blocks, remember that the torque setting is only 5 inch-pounds, don't over torque. If you've accidentally routed your line 2 PV conductors through the center of that production CT, you're going to see a negative value, as shown here in the installer app. Remove all of the line 2 conductors to correct the issue, and then verify the power production numbers again. Continue to the next step once the issue is resolved. Now that you've corrected the errors from the previous step, switch off the PV breakers. The current power production value is going to drop to 0. If it doesn't, that means the CT is measuring some amount of current running through the center of that CT that is not your PV. Double check that only the line 1 conductors from the PV circuits are going to be passing through the middle of that CT and nothing else. With the production CT out of the way, let's go ahead and dive into troubleshooting the consumption CTs. Once you're in the consumption CT setup process, make sure that you keep the PV production circuits off, and keep them off until the wizard tells you to turn them on again. Leaving them on is going to affect the coming steps, and it's going to give you some CT reading issues. The first step in the consumption CT setup is going to ask you if there's any PV installed outside of the system controller microgrid. For this troubleshooting video, we're going to be selecting the no option. The first thing you want to check on this screen is your producing number. That's in the upper right hand side. This value should be showing a 0 wattage value since you turned off your PV circuits from the previous screen. If you still see some amount of wattage going through there, double check your PV breakers, make sure that they're truly off, and that number shows 0. To the left of that is the consumption CT data, and that big number is going to be the aggregate of both your L1 and L2 measurements being added together. Both of those individual values you can see are directly below that number. The nice thing about this is you get to look at your L1 and L2 values independently. This is a great way to be able to identify if you have any polarity issues right off the bat. You'll see a negative value. In this instance, we don't see any negative values, so your L1 and L2 readings will add up to your 3.39 in this example. Where you place your consumption CTs is also really important. Your consumption CTs, as a best practice, is to put them on the main feeder lines coming in from the utility. And so for your consumption CT, that is for your L1 that has the black and red wires, that's going to go on your L1 feeder line from the utility. And your L2 consumption CT, which has the brown and purple wires, those are going to be going on your L2 feeder line from the utility. Now, when we talk about the polarity arrows, they always need to be pointing towards the loads and away from what you want to measure. In this example, we want to measure what's coming in from the utility, so the arrows are going to be pointing away from the utility towards the loads. If either of the L1 or L2 values show a negative value, there's really only two places where reverse polarity can happen. The first one is at the CT sensor that's attached to the feeder wire that's coming in from the main panel, or where the CT wires land on the gateway's terminal blocks. In this example, you can see that the L2 reading is negative. In the picture, it reflects that as well. And the polarity of the CT is pointing towards the utility, which is incorrect. Polarity arrows should be pointing towards the loads and away from the grid. Again, the great thing about this screen is that you can quickly identify polarity issues on a specific phase because each phase line has its own CT. One thing to note about this step, if you forget to turn off your PV breakers, you may see a negative value in the total home load. Be sure to turn off those PV breakers as indicated in the step. If you checked your CT sensors and you found that those are installed correctly, it's now time to go ahead and check your consumption CT secondary wires at the gateway's terminal blocks. We need to confirm that those wires are connected to the correct terminal blocks and secured properly. When we look at the consumption CT sensor that's connected to the line 1 utility feeder line, that's going to have that red and black wire. That needs to be connected to the C1 terminal blocks in the gateway. The CT sensor around the line 2 of the utility feeder line is going to have the purple and brown wires, and that's going to be connected to the C2 terminal blocks of the gateway. Make sure we refer to the wiring schematic on the door of the combiner box or on the lid of the gateway. That's going to give you the correct placement of each of those wires. If you verified that the CT secondary wires are correct and your CT sensor is correct, at this point, you may have a phasing issue that we need to address. Since we're on the topic of phasing, let's explain why phasing is so important in an Enphase system. Voltage and current readings must be from the same phase. So what does that mean? Remember that the IQ gateway needs two measured values to calculate power. Voltage and current for each phase is what the IQ gateway will use to calculate the meter reading values. Now, the voltage readings, they're taken from the power that is wired to the gateway's power terminal block. Terminal A is for line 1 from your electrical panel, and terminal B is for line 2 voltage readings wired from the electrical panel. The current readings are taken from the CTs, current transformers, that are attached to the appropriate phase lines. This principle just highlights the importance of ensuring that the voltage and current readings must be of the same electrical phase. If an installer wires incorrectly, or if the house is wired incorrectly, a voltage reading from line 1 and a current reading from line 2 would give an incorrect calculation for the power reading. Now that we understand why phasing is so important, we need to verify that the line 1 and line 2 power conductors going to the gateway are phased correctly. If the wires are not landed in the correct terminals, this is a phasing issue. Using a voltmeter, confirm that the service conductor, line 1, is the same conductor that is wired to power terminal line 1 of the gateway. Confirm this by testing the voltage between line 1 at the main service panel and power terminal line 1 of the gateway. The voltage should be 0 volts between these terminals and 240 volts between line 1 of the main service and line 2 of the gateway's L2 terminal. If you're getting a 240 volt reading when testing, test the line 1 voltage at every connection point downstream of the main breaker until you get to the gateway. If you've got a phasing issue, this will find the point where the phases have switched within the wiring. Correct the wiring and use a voltmeter to test again to confirm the fix. But what if you still see them? In some installations, the consumption CT wires could have been extended if the distance between the gateway and the utility feeder lines were longer than the supplied CT wires. This should be noted somewhere on the installation design and should be confirmed before going to the site. Extending the CT wires isn't a difficult task, but keeping track of the colors of the CT wires through the extended cable can pose a challenge, especially if those cables' splice point is in conduit. Enphase has seen installation errors with this process that shows up as reverse polarity. When extending the consumption CT wires, Enphase suggests 3 different cables to do so. You can find the recommended cables in the CT installation tech brief found on the Enphase website. These cables may not have the same color wires as the consumption CTs, so taking a picture of the spliced wires and noting which colors of the CT wires are connected to the extension cable wire colors will be crucial in troubleshooting CT extensions. In this example, the C1 consumption CT has its black wire connected to the black wire of the extension cable, and the red wire connected to the red. Where this is going to be different is on the C2 consumption CT, where the purple wire is connected to the green wire of the extension cable, and the brown CT wire is connected to the white wire of the extension cable. When connecting this extended wire to the gateway's terminal blocks, it's imperative that the correct C1 and C2 CT wires go to the correct terminal blocks. Because of the color change, you can see how this could get confusing if it wasn't documented during the installation process. As a best practice, write down which CT wire color was connected to what color of the extended wire. Refer to the gateway schematic for the correct placement of the wire colors and terminal block. Correct any wiring issues and continue to the next step. The next step in the process is to turn on an additional load. Now when you do that, your total consumption is going to go up. That's the expected result. If you turn on that load and that value goes down, check your L1 and your L2 readings. Figure out which one goes down when you turn on that load, so you may have to turn that on and off a few times. Once you discover which CT is incorrect, go ahead and start troubleshooting with the sensor. If that's correct, move on to the CT secondary wires being connected to the gateway's terminal blocks. If those are correct, you may have a phasing issue at that point. Once you verify that the home load has gone up and everything's fine, you can then go ahead and continue to the next steps. The next step in the installer app is to go ahead and verify the phasing to the gateway's terminal blocks. Don't skip this step, it's one that's overlooked way too often, and that's going to result in meter issues. So what you want to do is use a voltmeter with the power on, and you want to trace line 1 from the main service panel all the way to the gateway's line 1 power terminal block. When you do this, you should read 0 volts at every connection point. If you get a 240 volt reading, go ahead and verify where that phasing has swapped when you do that. Once that's corrected, then you can go ahead and do the same thing for line 2. Everything should check out and you get 0 volts for line 2 as well. That means your phasing is correct for L1 and L2 at that point. Once your phasing has been confirmed, go ahead and switch on your PV breakers and continue on to the next step. Once those PV breakers are on, it may take up to 5 minutes for them to start to create power. Now, as they start to produce power, you're going to see your production number start to increase, right? We want that number to go up. While that's going up, our home loads, what we see under our consumption, is going to start going down because that's less dependent on what we're pulling in from the utility. So as our production ramps up, our consumption being shown goes down, and we're still importing from the grid, and once it hits 0, it's going to start counting back up again, and you'll see the word importing change to exporting. What that means is we have more PV being produced than what we're actually consuming in the home, and now we're exporting that excess to the grid. What's interesting about this screen is that you won't see a negative value for your total consumption, but underneath there for the individual line 1 and L2 readings, you will see negative values only because the gateway is now reading that from the CTs. That's the raw data. And so the CTs are typically looking for current flowing in a certain direction of polarity, right, with that arrow. But as we're exporting to the grid, that current is flowing backwards through those CTs, which is going to give you a negative value. But because of the settings we've set within the gateway for the software, it knows that if we're going to be producing more than we're consuming, we may expect to see those CTs see a negative value, which we're assuming is going to be exporting back to the grid, which is why we're showing an exporting value there. Once everything looks good on this screen, we can go ahead and move on to the next step. If there is a storage CT in the installation, this section will cover the troubleshooting steps if there's an issue when commissioning the storage CT. Just like the production and consumption CTs, phasing for storage CT is crucial for the gateway to make a proper calculation to charge or discharge that battery. The storage CT must be installed on the line 2 conductor of the battery circuit, and the polarity arrows must also point towards the correct direction, which is towards the loads and away from the battery, as shown in this example here. But what happens when the app is showing a negative value for the storage CT? Well, this means that there could be a polarity issue with the CT sensor, the CT wiring in the gateway, or there's a phasing issue. Let's start with the sensor first, ensuring that the CT is on the correct phase line and that the polarity arrow is facing towards the loads and away from the battery. In this example, you'll see that the sensor is pointing in the wrong direction, which gives us that negative value. The second place to check would be the CT wire placement in the terminal blocks of the gateway. If the sensor is correct, wiring mistake could also show that negative reading. And in this example, you'll see that the storage CT is landed on the C3 terminal blocks of the gateway with the white and blue wires. We always recommend referring to the wiring schematic on the gateway or in the combiner box for proper placement. Make sure those wires are landed correctly and secure. So just like with the production CT, phasing is extremely important for the battery CT. Now the storage CT gets clamped onto the battery's line 2 conductor. This allows the gateway to measure the current for that phase. To get the voltage reading from that same phase, the gateway needs to be able to measure voltage from line 2 as well. You may have noticed the jumper in the gateway power terminal blocks. That jumper allows the gateway to be able to measure the voltage from line 2. So being able to measure voltage from line 2 with the gateway's power terminal block, the current from line 2 with the CT, that allows that gateway to now measure voltage and current from the same phase line. Make sure that the phasing is correct. Once any outstanding issues have been corrected, the CT commissioning is now complete, and your system should be free of any CT installation. Alright, now you've learned how to troubleshoot CTs with the latest version of the Installer app, and you should be able to tackle any CT installations like a champ. Just remember, when you do encounter an issue with CTs, most of the time it's going to be a CT polarity issue where either the CT sensor is pointed in the wrong direction, the CT wires are connected to the incorrect terminal blocks of the gateway, or you may have one of the biggest ones we see out there in the field is that you have the phasing within the system incorrect. Those three things need to be correct in order for the gateway to be able to calculate those measurements correctly. Thank you for watching another great video from the Enphase Learning and Development team. We'll see you on the next one.